I'm going to introduce the meet, okay?
Yeah.
Donc, I'm going to speak in French and English.
Okay.
Okay, good. Hello, everyone. Welcome to our AWS community group. Today, we're going to talk about what? Today, we're going to talk about the do and don't of DynamoDB. I'm going to share my screen and go look. Donc, bonjour tout le monde. Bienvenue dans notre communauté AWS Group, Congo-Brazzaville. Aujourd'hui, nous parlerons de ce qu'il faut et ce qu'il ne faut pas faire sur DynamoDB, qui est un service de base de données NoSQL sur AWS. Donc, je vais partager mon écran là, histoire que vous voyez un peu ce que nous avons. OK. I'm going to share my screen. Give me DynamoDB. OK. Tout l'écran. OK. 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 My screen is sharing. Est-ce que mon écran est partagé?
Yeah.
OK, thank you. So, donc, aujourd'hui, nous parlerons de Do. Donc, aujourd'hui, nous parlerons de ce qu'il faut faire et ce qu'il ne faut pas faire sur DynamoDB. So, today we're going to talk about what we're going to do and don't do in DynamoDB. Okay. Before everything, I'm going to introduce you our AWS group Congo-Brazzaville. Donc, avant tout propos, je vais d'abord vous introduire sur AWS User Group Congo-Brazzaville. Donc, I'm going to talk to you what it is and who we are and what we do. Okay. So, what about us? Donc, notre raison d'être, c'est que AWS Congo-Brazzaville, c'est un groupe qui regroupe, donc c'est une communauté en fait, qui regroupe les enthousiastes dans ce qui est dans le cloud computing, également ceux qui pratiquent le software development, tout ça autour d'une seule, donc tout ça autour d'un seul sujet, ou je peux dire d'une seule mer qui est AWS. Donc, en anglais, je pourrais dire, c'est à propos de, bon, what about, donc, notre raison d'être. What is AWS Group Congo-Brazzaville? AWS Group Congo-Brazzaville is the community of bring together the cloud computing enthusiast, the practitioner, developer software, anyone interested in AWS technology. Members. Today, aujourd'hui, nous comptons plus de 100 membres. Donc, today we have more than 100 members and more than 5 AWS accredited leaders. You can join us in a Meet, LinkedIn, or WhatsApp. Okay. Et à propos de moi, what about me? My name is Mishade Sajas Mukako. I'm a computer network security engineer, AWS Group Congo Brazzaville leader. My certification. I have a certification in a Fortinet certificate associate in cybersecurity, computer network security, AWS certificate cloud practitioner, and I have another certification. Okay. So I'm going to let Redis to introduce himself and introduce us in the topic of the days. Thank you.
Thank you, Mokako. Hello, everyone. Thanks for joining this session. We are going to talk about Amazon DynamoDB, more importantly, how to use it correctly. Before that, thank you for joining this session. I know this is the year end, like it's holidays, and yet you have chose to attend this session. Thank you. Thank you very much. Many people struggle with DynamoDB not because of it's bad, but because they're trying to use it as like traditional SQL data Today, like we'll start from basics, then we'll slowly build up on it. And by the end of this talk, we should understand what DynamoDB is good at, what it can't, and where it can go wrong, and how to avoid common mistakes, like taking the recent case studies as well. All right. Uh, okay. Let me introduce myself. I'm Bonkur Harshit Reddy. I'm a I'm just a bachelor student. I'm not an expert, but uh, I have studied about DynamoDB and deployed it like once, but I attended many talks and many sessions where they taught me a lot of things. So I'm going to share about them. These are my basic introductions. I'm also a co-founder of a company called Tropian Private Limited, which is basically focuses on drones in agriculture. We are just building on it, and uh, I'm also an TCS Code Vita, which is basically in what do you say, coding competition. I'm got a global rank in it, and I'm also an AI agent architecture where I've built agents for uh, agriculture based uh, in for identifying diseases and all. I'm also a AWS cloud practitioner, and I also have other certification in Azure and MongoDB as well. Also, I have a, community called r/Indian Devs, which has 10K members in it, which is focuses on engineering and development relating to software and related. Also, I have also published two research papers in IEEE, which focuses on Alzheimer's and Parkinson's. This is a quick introduction of the. Let's proceed to this session. Thank you. Okay, why DynamoDB exists? Like, why can't we just use simple SQL? Um, SQL databases like MySQL, Postgres work well until the traffic increases suddenly. Then you face slow queries, locking, scaling pain. This is why DynamoDB was built to guarantee a single date millisecond latency, even when the traffic like suddenly goes up. Like let's say when Amazon starts a new sale, or recently Stranger Things new episode dropped, right? Like in Netflix servers, the traffic suddenly went up. In these cases, you use DynamoDB. Like you expect like sudden growth of traffic, right? In these cases, you use it. Okay. Now, SQL versus NoSQL. When to use DynamoDB? First, what's SQL? SQL means structured query language, and NoSQL means not only SQL. DynamoDB is an NoSQL database, kind of like MongoDB. That means, like SQL, we don't need any joins, no complex queries, no ad hoc analytics. So we use DynamoDB only when access patterns are known in advance. Like when we are assuming that there's going to be this amount of traffic or this amount of analytics is going to come in. Like we don't use DynamoDB if we need to use any joins, we need any reports, we need any fixable queries. In these cases, we don't use DynamoDB. DynamoDB is made for applications, not for analytics. Analytics is great done by the traditional relational databases. Okay, let's go deeper into DynamoDB's internal architecture. Okay, in this slide, you can see partitions, hashing, and limits. The DynamoDB is a distributed system, not a single server. Every item is placed into a partition using a partition key. Partition key is hashed. that decides where the data lives physically. Each partition has physical limits. Like let's say, I think it's about 1,000 uh, WCU, which means write capacity units, and about 3,000 RCU, which is read capacity units. AWS adds features like adaptive capacity, but it cannot break the physics. So one hotkey can still destroy the performance. So we need to mind these things. Okay, let's go in further deeper. Why scans are a disaster? In this slide, you can see like query versus scan comparison. What you can see is a query uses a partition key, but DynamoDB goes directly to the correct partition. This is fast and cheap. Instead of like traditional it searches for throughout the rows and all. A scan reads every partition in the table. It consumes massive RCUs and money. Like we are going through everything, right? That's why. Scans are acceptable only for like one-time scripts, offline analytics, but never use scan in production request paths. Next, data modeling and access patterns first. Like what this slide shows that do's and don't in modeling. In SQL, we model entities. In DynamoDB, we model questions like get user profile and like get a user's last 10 orders like that. DynamoDB wants this answer in one query. That means pre-joining data. Here, we do not normalize like SQL. We move up. We shouldn't normalize at all like SQL because this is a NoSQL data. Like since we are using DynamoDB. Okay. Now we move on to single table design. In this single table design, we see benefits and the cons. In single table design means storing multiple entity types in one table. Like what are the benefits? One query, lowest latency, lowest cost at scale. There are cons as well, like more complex writes, more application logic. Yeah, we have to like specifically create according to the application. So we need skilled engineers at this. This is an architectural trade-off, not a beginner trick. So we need to practice a lot before pushing this into the production, and we need to test a lot. Right. Now, hot partition and their anti-patterns. Bad partitions and their consequences are a lot. In this, a hot partition happens when too much traffic hits one partition. Like let's just say um, the a sale is specific to this this specific region, let's say New York. It's the sale is only at that region only. Then everyone in like suddenly the traffic increases in that region only. So in these cases, what we need to do is like what are the common mistakes in this? Using like status as an partition key and using a date or a timestamp, using sequential identities, which results in throttling, unpredictable latency, and wasted capacity. Yeah, we don't want that. Okay, let's move on to the techniques to like how to avoid these. Like these techniques, right sharding techniques. There are three techniques. Let's go one by one. In this, there are techniques which are random and which are calculated sharding. Sharding means splitting the write across multiple keys, like splitting the load, as you can see. Random, let's go into the types. Random suffix sharding, which is easy, massive write scale, read becomes aggregation, and calculated sharding, predictable reads, more complex logic. But price wise, this is still cheaper than throttling failures. So whichever the method is, it's still better than like throttling, like larger latencies, of course. Okay, let's move on. This is the third one. Indexing in DynamoDB, it has two types, GSI and LSI. Let's see what they are. GSI means Global Secondary Index, and LSI means Local Secondary Index. LSI has hard 10 GB limit per partition, so you cannot delete LSI later. You cannot at all. Whereas GSI, it scales independently, can be deleted, eventually consistent. Eventually, the keyword, because it doesn't start off as good, but you in the long term it becomes consistent. So here the architectural rule is preferred GSI unless strong consistency is mandatory. Okay, let's go into the indexes further. Sparse indexes. These are basically the hidden superpower. Sparse, sparse index means only some items appear in index. If attribute is missing, item is not indexed. This is perfect for work queues, pending jobs, inbox patterns. This right here dramatically reduce costs in these scenarios. Okay, let's go into capacity modes and pricing, like the definitive do's and don'ts. Here, on demand, you pay per request, best for spikes. And in provision, cheaper for steady traffic, and auto scaling has a lag. So we have to mind the lags as well. Rule is spiky on demand. Like if there's a spike in sudden increase of traffic, when we use on demand. If it's predictable, we use provision ones. Like the Christmas sales, New Year sale, you can predict that, right? Like there's going to be a traffic in this time segment only. Like this upcoming New Year sale, the then recent Black Friday sale. Like these happen only once in a year, and in these specific dates only, right? Then you can use provision. Like what if there's a sudden spike in or like some show releases or some sudden trend goes in social media, like then we use on demand. Okay, now cost engineering. Like we have to mind because we don't want to end up with a big bill, right? DynamoDB prices is per KB and per request. Uh, for the do's, we have to short attribute names, bash the APIs. We use DAX. DAX is basically AWS's tool, which is DynamoDB Accelerator. And for don'ts, we do not have to store large documents in it. Whenever we have to store any large documents, just dump it in S3 and then do on top of it and then call from it. That's the best method. Instead, store the payloads in S3, like simple storage service. Keep only S3 keys in DynamoDB. So that in this case, you won't lose any performance as well. All right, let's go to the case study. This case study is quite popular. You recently experienced this as well. Um, this slide introduces a real-world DynamoDB failure, not a theoretical exam. Literally happened this October, if you guys remember. Up to now, we talked about design mistakes made by developers. Now, I want to show something very important. Even AWS itself has experienced major DynamoDB related incidents. This case study is important because it proves two things. DynamoDB is extremely reliable, but it's not magic. It can fail. Most large outages are not caused by DynamoDB's core storage engine. This incident did not happen because DynamoDB was slow or overloaded. It happened because something called the control panel, which I'll explain later. Okay, now the slide 7. What the data plane actually reads and writes control plane, which is basically the management operations. To understand this failure, we must understand two very important things. What's a data plane? This is the part where DynamoDB reads data, writes data, serves your application request, and the control plane. This is the part where DynamoDB creates tables, updates capacity, manages metadata, handles internal coordination. During this incident, the data plane was healthy. Existing DB tables could still read and write data, but the control plane failed, which means new tables could not be created. Scaling operations were stuck. Some services, depending on this meta data, started failing. This is why many AWS services appeared down even though the storage was still working. Okay, next. The cascade effect, how one failure become many. Like this caused this chain effect. Like shows how one small failure spread across systems causing large outages. Now comes to the most dangerous part of this incident, something called cascade failure. Here's what happened. I'll go by step. Like in first step, the DNS, like domain name system automation bug occurred inside AWS. Next step, what happened is this caused delays and errors in DynamoDB control plane. After that, AWS services that depend on DynamoDB metadata started failing. After this, application built on top of these services also start failing. Importantly, many applications made the situation worse by like they retry aggressively, not backing off, assuming the retries are always safe. So each retry increased the load on already stressed systems. This turned a small internal issue into a large regional incident. That's why, they fixed it within 2.5 hours, but it extended it to 16 hours. This is the reason. Like Cascade, why 2.5 hour bug became 15 hours? Like, why did it happen? There are three critical lessons from this case study. Lesson one: manage does not mean invincible. Yeah. Oh, 1 minute. Okay, what happened next? Oh, Lex was EC2 lease renewals phase, auto scaling stalled, millions of control plane writes queued. Basically, it created, let's say, when a pipe is interrupted in between, like huge pressure is built, and suddenly when the tap is on, huge water flow came. So basically, this is like the documents they came in so many requests. That's why the lag. So after the DNS was fixed, like this massive storm came in, like DynamoDB and EC2 instantly saturated. No system could drain this backlog, and this went into the failure mode, which metastable system alive but unable to recover. Like it. it's too much to hold it on its own. Like one third of the internet's requests coming all together, literally. Okay, solution is how AWS recovered. Like what they did was the recovery actions is global throttling introduced, corrupted queues purged, they restored the control plane, DB state was rebuilt gradually, caches were warmed slowly. So the key lessons learned here are managed does not mean invisible. Even fully managed services like DynamoDB can experience control plane failures. Yo, literally one third of internet went down that day. Listen to like retries must be designed carefully. Like blind retries without backoff can turn a minor issue into a major outage. Even though AWS fixed it in within 2.5 hours. But since they were blind retries and incoming huge amount of like incoming queries, that caused it into a 16 hours outage. Even though they fixed it way before. Lesson three, like regional dependency is real. Like literally one third of the internet was depending on US East 3. So even though AWS says to its clients, use multiple regions, multiple availability zones, no, don't just depend on this one, that one. You should be spread across throughout the world. See, as you can see, even though that's their main uh, data center, but it failed. Not everything is invincible. That's why we should plan accordingly. So, this is why exponential backoff is important. Circuit breakers are important. Multi-region designs matters a lot for these critical systems. DynamoDB is extremely reliable, but architectural decisions still matter. Like one wrong decision, see how like literally one third of the internet gone. Okay, finally, oh, yeah, these we discussed this. Okay, how this applies to your architecture? You, what you have to do, use multiple region designs for critical paths, use DynamoDB global tables where appropriate, and you do not need to use it for like normal tables for storing data. No need for that. Use it for applications only, and implement retry budgets and circuit breakers. Like whenever it shouldn't just blindly retry. When you have to like at time you have to give it a timeout instead of just blindly retrying, which will just well, like when the service is back, it will just cause a backlog. It will further extend the delay. What you have to don't is assume a region will never fall. We everyone assumed that AWS East 3 will not fall, but it fell. And don't assume that managed services recover instantly. Everyone assumed it as well, so they were blindly retrying. It only made things worse. And also, don't allow unbounded retries. You have to implement circuit breakers or at least implement some timeout. So this doesn't happen to us. Okay, final do's and don'ts. What you have to do is model access patterns first. Use a single table design. Use high cardinality partition keys. Prefer GSIs over LSIs. Use S3 for large blobs. Blobs is basically large amounts of data. Implement right sharding. Use sparse indexes for workflow states. Enable PITR for safety. Monitor hot partitions. Like uh, put a separate watch out for it, like alerts and all. Okay, what you have to don't is don't scan tables. Don't. It will increase your costs. It's very expensive. Don't use sequential or timestamp partition keys. Don't normalize data. If it's in DynamoDB, don't. Since it's not SQL, this is no SQL. Don't over-index. Like if you over-index it, like it keeps on searching, which will increase the time and resources used, which will increase the bills. Don't store large documents directly. Store it in S3. Like DynamoDB is not meant for storing stuff. S3 is meant for storing stuff. Don't rely on auto scaling to handle sudden spikes. You have to configure it. Don't ignore the 10 GB LSI limit. If it goes above, then new problems arise. Okay, final thoughts. DynamoDB failures are but really occur, but it's always about the performance. They're almost always about design dependencies and assumptions. So we have to test, then like push it to production. All right. Any questions?
Okay, you can see the question in the when we sent message. I think.
Okay. Question. What would be the advantage of using DynamoDB compared to a database managed from my EC2 instance? Since with EC2, I have more control over my database. Okay. It shouldn't. Let me check. Let me just check in my logs. Double check.
Hello,
I'm
can you hear
finished.
me?
Okay. Yeah.
Yeah.
Yes.
Hello.
Yes,
Yeah. We
yes.
can hear you, William.
Okay. So I was thinking probably for the first part of the question that what would be the advantage of
Oh,
using DynamoDB compared to a database managed from an EC2 instance, right? Uh,
okay.
yes, the person is right. You have more control over your database, but there's also a fallback, if you can say it. Let's remember the shared responsibility model from AWS, right? If you want to take more control of your infrastructure, where if it's databases, computing, networking, you can do it. AWS has services for that, but it also will mean that you will be directly responsible for all administrative overload, right? And in some companies and in some projects, you would prefer to focus only in your application, in your data, in how you directly create things for your users. So it's not that is better one way or the other. It would depend exactly on the requirements of your project. If your client tells you that you need to have more control over your deployment of your database, yes, you can go with an EC2 instance, and inside it you can install the software you want. But if you want to leverage on AWS, I will absolutely will go with the DynamoDB service that Harshi has explained us this afternoon. And the other part, how can you secure your DynamoDB from any attacks like DOS or SQL injection when your
You
DynamoDB working with a website?
let me
Yeah, yeah, go, my
DynamoDB.
friend.
Oh, DynamoDB is not vulnerable to SQL injection. If they are, I would do it already, but they're not. Since they are founder of this already. Why? Because SQL injection attacks work only on SQL databases. DynamoDB does not use SQL. You never send raw query strings like select from users where Instead, DynamoDB uses structured API calls, explicit parameters, and typed attributes. So attacker cannot inject commands into DynamoDB query. SQL injection is not applicable to any DynamoDB. Then what can be attacked, you may ask? They attack your website, your API, your authentication, your request volume, like normal DOS attacks. So Dynamo sits behind these layers. What they do is, okay, first let's say what's an DOS attack. First, an attacker sends a huge number of requests. They overload your system, then increase your build, and then make your limit go off so that your service stops. Like normally you set in budget, right? If this budget hits, your service is stopped. They want that. So but the main thing is attackers cannot hit DynamoDB directly from the internet. They only can hit your front end and your API. So how AWS protects your DOS is like AWS Shield. I have studied this in my cloud practitioner. This applies for DynamoDB as well. The AWS Shield standard is always on, and it protects against network threats, protocol attacks, and volumetric DDoS. So we don't need to do anything about it. AWS protects this in infrastructure level attacks only. We literally don't have to do anything about this. And the second is AWS WAF, like Web Application Firewall. So in this, we have to use in WAF we use is this it's used in CloudFront and API gateway and application load balancer, if I'm correct. AWS WAF can block IPs, block countries, rate limit requests. Like these are specific, like what do you say? If they created an account and doing maliciously from the inside. This for that case scenario. And for what if we say another threat like someone calling DynamoDB directly, this shouldn't be possible because DynamoDB credentials are in browser, JavaScript, mobile apps, and front-end code, which aren't exposed. And again, if they try to attack this directly, AWS Shield standard is always on. So they're protecting us at infrastructure level. If they could take down that, they could literally take down the AWS itself. I think no hacker is that intelligent or no, like they won't do targeted amounts in your business because if they could, they would target much bigger $1 trillion companies than you. Yeah. Okay, another question. What are the ideal measures for security in DynamoDB? Okay, I've mentioned this in the slides. Let's go to them again. Like, first principle, like literally who can access it, how it can be accessed, from where it can be accessed, if an abuse is detected, how it can be limited. Okay, let's go in a checklist wise. Like first one, identity. Like in AWS, I am just give the minimum rules to whoever using it. Like this is the first principle where AWS teaches us in the certifications as well. Like give least privilege, so nobody has full access, and like developers who access can have wherever they require to make changes. And if someone else is from another team, they can only just view the table, or if not, no viewing at all also. uh, for an example, let's say a backend service, they can only, if and developers like working on a backend service, they can only read and write on the table. If someone is from another team whose job is analytics, they should be only able to read. So they should only have read only access. So both of these, like no delete permissions required for both of them. Like they don't need it. Okay, the second one is never expose DynamoDB to the internet. Like never. Why would you want to? Put these AWS credentials in the front end code. Allow browsers to access DynamoDB directly. Like don't expose it. Only trusted backend services should be able to like talk DynamoDB using IAM rules. So this blocks direct attacks on database. Another is the authentication and authorization. In this common solutions, we can use Amazon Cognito and OAuth, session-based authentication. So what it does is per user permissions, rate limits per user. Like if some user goes rogue, they have rate limits, so they can't just do as much as damage they want because there are rate limits. If they want more, they need to request it. And so this obviously prevents abuse. Another thing what you have to do is like what Mr. Previous question was how to prevent DOS and DDoS attacks, like AWS Shield. And this is enabled in infrastructure level. But what if in application level? In that you have to just configure AWS WAF like we discussed before, right? And for encryption, this is required because since the traffic comes on the web, so we need to specify that all the traffic should come from HTTPS alone, no other way. And DynamoDB encrypts all data by default, so we don't need to worry about encryption. If you want, you can use AWS key management service. It's recommended. Yeah, it's very recommended. It's basically makes your life easier, but you have to mind it like how you are doing it as well. And that's probably it. The other was network level isolation and input validation, monitoring, these and all. Like you have to do it for every services as well, not only DynamoDB and all. Like you have to keep backups, recovery if something goes wrong. These are common for everything. Any other questions? Okay, for which specific niche we should use DynamoDB? Okay, for that, in the starting we went through like SQL and NoSQL. We'll go through it again. Like what is DynamoDB is designed for? Like it's not a general purpose database. It has specific needs. Like uh let's see like what if massive scale with predictable performance. Like what is this problem? Like traditional databases like SQL ones, like they become slow as the data grows, traffic increases, and concurrent users increase. In these cases only, we use DynamoDB. Like they increase suddenly, right? SQL databases cannot handle this. In this, we DynamoDB is specifically designed where like read and write latency stays in milliseconds, and performance does not degrade even when the data size increases. So we used DynamoDB when you expect thousands to millions of requests per second. Like if you have less than thousand, use an SQL. Like no need for DynamoDB. You cannot tolerate performance drops under any load. Like if it's you need this website up constantly without any performance drops, you're gonna use DynamoDB at that time. like user profile lookups, high traffic KPIs, or let's just say a game has specific this leaderboard which needs to be stay up all the time. Okay, another use case is like if the traffic is unpredictable or it just keeps on spikes, goes up and down. In that, many systems don't have steady traffic, like as we have discussed, flash sales, viral events, news spikes, like some launch events. In these cases, we again use DynamoDB, where it automatically scales up and down, no warm up time, no manual sharding. So we use DynamoDB when you cannot predict this traffic patterns, sudden spikes which cause downtime, like e-commerce carts, event ticketing, mobile app backends, like uh, when there's a sale going on, or some movie release, some series just got released in, like Stranger Things was released in Netflix, and you experience no lag, right? Because they use DynamoDB. Now, another is low latency, simple access patterns. So, this very DynamoDB is very ideal when you know your queries in advance. Like queries are simple and repeatable. Data can be accessed by a key. Like good access pattern, get user by ID, get orders for user, get latest events. These are these access patterns are very ideal for DynamoDB. You shouldn't use DynamoDB if this is your like access patterns, like ad hoc filters, complex joins when you're joining. No, that's for your normal SQL based databases, not for DynamoDB. Or if you have multi-table analytics, you want some data to be extracted from multiple tables. DynamoDB is not ideal for this. For these, you shouldn't use DynamoDB. And if you want to go serverless or low operational overhead, you use DynamoDB as it scales automatically. And yeah, this has high availability and fault tolerance by default. But still, you should keep settings across multiple. You shouldn't just leave it as it is. As you know, AWS East fell literally one third of the internet gone. So that's about it. Main selling point. I forgot about this. Schema flexibility, the NoSQL's biggest advantage. Like different items to have different attributes, easy evolution of data models. But primary keys are fixed, access patterns must be planned. Like you need to like make tables in such a way that your queries are like whatever your queries are you planning to do are optimized for it only. So use DynamoDB in this case when you have control of how data is accessed. Okay, now let's go like when you shouldn't use at all. When you need complex joins or heavy index, query patterns are unknown. If it's unknown, just stick to relational database. You'll save a lot of time by like in money and response time as well. If there are strong relational constraints, also then don't use DynamoDB. And if the query logic changes like frequently, like when it changes because you make changes in table frequently, then also don't use DynamoDB because it needs to be planned like way before. Okay, any other question? Oh yeah, in our intrusion data. Okay, what are the okay? Firstly, what are the key CloudWatch metrics to monitor for DynamoDB? Uh, William, could you please take this question? please, what are the key CloudWatch metrics to monitor for DynamoDB?
Yes, I'm looking for the official documentation because, as we know, CloudWatch is the integrated service for monitoring in AWS, and I'm looking for the available metrics. But I think that they will be like integrated into cluster, into tables, and probably what you mentioned before, reading, writing units. So let me find it and continue with the other question, Harshit, and I will post it
Okay,
in the chat. Okay.
are intrusion detection services integrated into DynamoDB? No, DynamoDB does not have an inbuilt intrusion detection system. However, AWS has multiple integrated security and monitoring services, which we discussed, like AWS Shield. That's one of it. And what are the others? Like, why doesn't, okay, let's first get to this. Why doesn't DynamoDB doesn't have an inbuilt intrusion detection system? Because AWS manages a serverless service. You do not control the OS. AWS controls it because it's serverless. You do not manage the network interfaces because AWS manages this. You cannot install host-based intrusion detection tools like, let's say, Snot or OSEC, because AWS is managing us all. So basically, you are
Harshit,
using it service level. Yes.
no, sorry, I say that in the chat we will
Okay.
find the metrics specifically for DynamoDB.
Okay. Like how intrusion detection works for DynamoDB. Let's say in practice, in AWS CloudTrail, like primary detection layer, where you CloudTrail logs every DynamoDB API call, and this basically allows detection of unauthorized access attempts, suspicious API usage, like if someone's trying to take your table down, if some developer has gone rogue, unexpected table deletions, like in these very rare cases, like if your developer goes rogue, in those cases only, and privilege escalation. Okay, another thing is another service I think is Amazon Guard Duty, where it analyzes CloudTrail logs, IAM activity network patterns from BPC logs. For DynamoDB, Guard Duty basically can detect access from unusual locations. Okay, when let's say if your whole services are based in Africa, if I'm accessing it from India, then it flags it. Like, "Oh, what am I doing from India to your services in Africa?" That's very suspicious. And compromised credentials, like if the credential is used multiple times and like from multiple location, that's a suspicious activity. So it basically flags that as compromised credential. And if API calls are from known malicious IPs, AWS has large directory of like malicious IPs. They keep this large directory, so it's basically like whenever you get a call from a like advertisement, your phone flags it, right? This is an spam call. Please ignore it. Same logic. AWS does this with IP addresses. And another is CloudWatch alarms. Basically, if there are certain spikes in read write traffic, unexpected scan operation, for these you create alarms for it. And yeah, we another is AWS IAM, like least privilege. We discussed this. And okay, yeah, this can be also used like AWS config. Like it changes the DynamoDB settings, IAM policy modification. We can encrypt and backup compliances. And also it what it basically does is if there are any misconfiguration, if someone is tinkering with your settings, it identifies it, like someone is like removing the security policies and all. This flags that and it notifies you. That's Yeah, that's about it. Any more questions?
For me, I think it's good. I have no question to ask.
Yeah, please do.
Any question?
No question for me.
All right. Thank you all for once again. Like I know this is a holiday season, and yet you have chose to come here. Thank you for that.
Okay. So I
Happy
think we
holidays
can.
to all of you.
Thank you so much. Okay, I
And
think
I
we can.
thank Mr. Sagesi and Mr. William for this opportunity. And thank you for this group.
Thanks to you.
Thank you so much. Thank you. Thank you. Okay.